Salutations, everyone. Dustin here. I have a question. Have you ever wondered how money goes in a bank, how population increases, or why do videos go viral? They are all connected to sequence and series. Sequence help us find patterns and predict future values, while series help us calculate totals. So basically, it's just a sum of the sequence. They are used in finance, science, engineering, and everyday life. Today, we'll learn how these simple number patterns can explain real world growth and change. So, let's get started. Before we begin, let's actually set some vocabulary. So, a sequence is defined as a set of numbers or an ordered list of numbers that follows a specific mathematical rule or pattern. So, it's just not just like a random 2, 5, 7, 3, 6, 4, whatever. It really follows a pattern. It could be just adding or subtracting, or it could be multiplying or dividing. And a series is basically just a sum of the numbers in a sequence. So an example would be 1, 3, and 5. This is a sequence. And more specifically, this is an arithmetic sequence. The reason being is that the difference between the first term to the second term and the second term to the third term and so on is just the same. So the difference between 3 and 1 would be 2, and the difference of 5 and 3 would be 2. This, however, let's say 3, 8, 12 is not an arithmetic series. Reason being, their difference, 8 minus 3, 5, 12 minus 8, 4, is not really the same. Basically, an arithmetic sequence is when our common difference, or the difference between the second term to the term before it, is the same as any number in our sequence. A geometric sequence, however, is practically just the same as an arithmetic sequence, except we multiply by a value instead of adding. So let's say 2, 4, 8, 16. As we can see, the difference of 4 and 2 would be 2. But the difference of 8 and 4 would be 4. Difference of 16 8 would be 8. As you can see, they're not the same. However, it still follows. Based on definition, it follows a specific order or a specific rule or pattern. As you can see here, 2 to 4 and 4 to 8. They just multiply by 2. So we can determine that this is a geometric series because the difference, or in this case, the common ratio, is the same, 2, 4, and 8. A series, on the other hand, just asks what is the sum of the total number in a specific set. Let's say 2, 4, 6, and so on until the 8th term. So what this just asks is from the first term, which is 2, to the 8th term, let's denote it as a sub 8. If you add them all up, you get its series. A geometric series is practically just the same, except instead of the sequence following an arithmetic path, it follows a geometric one. So let's begin some solving. So find the common difference and the 15th term of the arithmetic sequence 7, 12, 17, 22, and so on. So in order to solve this, we must first find the common difference. So let's set this as a sub 2 and 7 as a sub 1. So we do 12 minus 7, which we get 5. This is our common difference. So we already solved this. Easy, right? Now for the second part, 15th term of an arithmetic sequence. So we write the formula again for an arithmetic series. A sub n equals a sub 1 plus n terms position minus 1 times the difference. So we just plug in the values. A sub 1 is the first term, which is 7, plus n, which would be 15 in this case. 15 minus, 15 minus 1 times our difference, which we already saw was 5. So just calculating this, 15 minus 1 would be 14, times 5 would be 20. So calculating it, we get 15 minus 1, which is 14, times 5, which is 70, plus 7, or we get 77. So our common difference would be 5, and our 15th term, or a sub 15, equals 77. Let's see a similar example. Find the missing term and next two terms in the arithmetic series -4, 1, 6, blank, 16. So, first things first, we look for the common difference. So we use 1 minus -4. So 1 minus -4 is 5. So our common difference would be 5. Now using basic logic here, the term here 6, we need to find the next number. We'll just basically add the common difference, which is 5. So 6 plus 5 will easily get 11, sorry. So the fourth term here would be 11. And so on with 16. It asks for the next two terms. So what we can do here is 16 plus 5, get 21. The next term after 21 would be 26. So 11 would be the missing term, the underlined term, and 21 and 26 would be the one in line after 16. Moving on. Write the first 6 terms, an explicit formula for an arithmetic series, a sub 1 being 18 and the difference -3. So let's write the formula first. A sub n equals a sub 1 plus n minus d. Sorry. So let's write the formula first. A sub n equals a sub 1 plus n minus 1 d. This is our explicit formula. So we just basically plug in the values. Our a sub 1 would be 18, and it asks us for the first 6 terms. So let's start with the second term, third term, fourth term, up until the 6th term. So 18 plus second term minus 1 d, and our d would be negative 3. Common difference. So 2 minus 1 would be 1. 1 times negative 3 would be negative 3, plus 18 would be 15. And let's just solve for the other 6. Get 18 plus third term minus 1 times 3. I'll just write it out so it wouldn't take much time. So we have it. Let's start with the third term. 3 minus 1 would be 2, times negative 3 would be negative 6, plus 18 would be 12. On to the next one. 5 minus 1 would be 3. 3 times negative 3 would be negative 9, plus 18, it will be 9. As you can see, you don't actually need to write all of these formulas, because as you can see here, we have 15, 12, and 3. As the list goes on, we can clearly see that it gets subtracted by 3. So we can just go by 15, 12, 3, minus another 3. So we get 6 and 3. So this would be our answer. 15, 12, 9, 6, 3. So our A sub 6 here would be 3, and so on and so forth. So we'll be moving now in arithmetic series. This asks, find the sum of the arithmetic series 3 plus 7 plus 11 plus so on so forth until we get 99. So let's just write the formula real quick. Arithmetic series equals the number of terms divided by 2 multiplied by 2 times a sub 1 plus n minus 1 d. It's quite similar to the arithmetic sequence, except we have this n over 2 and this double a sub 1 thing. So how I would approach this is I would first find the common difference. So we take here 7 minus 3 equals 4. So this would be our common difference. The thing about here is we can't really know things here. So for example, this n, we don't really know how many terms are in 3 to 99 with a common difference of 4. So what we do here is, so as you can see here, we actually have a few variables which we don't really know. For example, this s sub n, it asks for the total amount, which clearly in the question we don't have, and neither do we have the n, or the amount of terms within this sequence. It would be rather tedious to count from 3, 7, 11, 15, and so on. So a strategy you can use is we refer back to arithmetic sequence. So we have again a sub n equal to a sub 1 plus n minus 1d. With this, we can actually calculate what the 99 term is, the value 99, what the term of it is. So we plug in a sub n as 99, a sub 1 is 3, plus n, which we do not know, so we leave it as is, minus 1 with a common difference of 4. So we'll just do some basic algebra here. We'll move this positive 3 to the left side, which gives us 96, and 96 divided by 4 would be 24. we move this one to the other side, and we get n equals 25, or 99 in this sequence is the 25th term. So now that we know what n is, we can solve for this. So let's calculate for it. Series over 25 over n. So the series is equal to 99. So the series is 25, or the 25th term, over 2. A sub 1 is 3, so 3 times 2 would be 6, plus 25 minus 1, and our common difference 4. So let's start here. 25 minus 1 would be 24, times 4 would be 96. 96 plus 6 would be 102. This is quite messy actually. So 25 over 2 times 102, and calculating this, we would end up with 1275. This is the sum from 3 to 99 with a common difference of 4. Another example. Find the sum of the first 40 terms in the arithmetic series 12, 17, 22, 27. Now this is actually easy because we don't need to do some solving for n because we already provided with 40. So let's put it again. Our trusty formula. I actually just realized I actually used the parentheses wrong. It should be this bracket, and the parentheses with a curve is inside. Okay, but whatever. I hope you didn't notice that. Anyways, we have this n minus 1. So our n here would be 40 over 2. And our first term would be 12. So 12 times 2 is 24. Plus our n, 40, minus 1, 39. Times d, which is common difference, 17 minus 12 would be 5. You can easily do this in your head. You don't really need to write every single number down, especially during an exam where it'll be very, very time consuming. So 39 times 5 would be 195, plus 24, 219, times 40 over 2, and we will get 4,830. Quite easy, right? So moving on. This one is actually much more practical and more intuitional. So we actually have like a real life application. So this goes, a theater has 18 seats in the first row. So the first row would be 18, and 4 more seats in each succeeding row. So we have like 18 plus 2. Oh, sorry, it's 4. Silly me. Anyways, and then 18 plus 8, and so on until 25th one. Now, this actually asks for the total, meaning we will be using arithmetic series again, or we'll add them up until 25th term. So let's start. For the last time, I'll write the formula. Sub n n minus 1 times d. So our n would be number of seats in a row. It's 25 over 2. Now the first term would be the 18 seats, as it is the first in the row. So 18 times 2 would be 36 plus n, which is 25, minus 1, so 24, multiplied by the common difference, which would be 4. So 24 times 4 would be 96. 96 plus 34 would be 132 times 25 over 2, and plug in the calculator. We get 1650. So from the first row to the 25th row, there are a total of 1650 shares. So quite easy. So now we'll be moving on with arithmetic mean. So as you all may know, a mean is an average within a set amount of data, or in our case, sequence. So this is asks just basic question: insert one arithmetic mean between 14 and 30. So basically just plug in one number in between 14 and 30. 14, 30, a number that is evenly split between them. So for this, we actually have a formula, as you saw earlier, which is a plus b over 2. And then if you plug this in, get 14 plus 30 over 2. So 14 plus 30 would be 44, divided by 2 would be 22. So our answer here would be 22. But as you may have noticed, moving on to a similar mean, insert two arithmetic means between 5 and 20. This time we need two values. So 5 blank blank 20. So as you can see here, the mean doesn't ask for an odd number, meaning if we try our original one, which is 20 plus 5 over 2, we get 25 over 2, or 12.5. But where would we put this 12.5? Would we put it here? Or would we put it here? Well, you can't really put it there because it's an even number, so it's practically in between them. So what we need to do is do some magical transformation and manipulation, a bunch of linguistic jargon, but we'll just refer back to our lovely equation. A sub n is equal to a sub 1 plus n minus 1 d. But you might ask yourself, how how could we possibly use this equation in order to solve for this? Well, notice that there are 4 terms here, and that the first term is given and the fourth term is given. We could actually use that to find the common difference. And once we get the common difference, we can simply add it up to 5 and add it up to another one, which just completes the set. So we plug it in. A sub n is equal to 20, right? 20. And our first term would be 5 plus the amount of terms, which is 4, minus 1. Since we need the d, we just leave it right here. So we move this 5 here, so we subtract both sides by 5. Get 15 is equal to 4 minus 1 should be 3 times the common difference. We divide both sides by 3, and then we end up with 5. Our common difference is 5. Now we just basically add this up. 5 plus 5 would be 10, and 10 plus 5 would be 15. So the two arithmetic means between 5 and 20 would be 10 and 15. That easy. And with that, this concludes our video for arithmetic, series, sequence, and means. In the next video, we will learn about geometric ones. Yeah, very, very interesting. Geometric sequence, geometric means, geometric series. Those fun stuff. But for now, we have what arithmetic has to offer us. I hope you learned quite some things. Quite a lot, hopefully. And yeah, just keep on practicing and you'll be absolutely phenomenal in this game of math. You know, the most hated subject. The best feeling is just to be great at something everyone struggles at. Okay, but besides that, I hope you learned a lot, and yeah, farewell.